Hello everyone, my name is Maxime Chagnot. I'm a CATIA consultant working for PLM technology in Norway. Today I will perform a live demonstration of the 3DExperience release 19x on cloud. And many subscribers of the YouTube channel asked me to do a video about mechanism in 3DExperience, so today that's the topic. I got inspired by an Instagram page called CAD GIF. I'm going to show you that. I really recommend you to have a look at this. It's plenty of animation of a small mechanism, and it's super cool. And I get inspired by one of them. I find it pretty interesting. It was this one, a Double Cardan mechanism, and I think it's kind of nice because you have several kinematic connection between this. You have several revolution in that, but you also have a prismatic here, and you have a gear connection. So my point today is to show you how we can reproduce this animation in the 3DExperience. So the video will be divided in two parts. First, I will show you how we can assemble this mechanism. So I've already created the parts, and you will be able to find them on the GrabCad page. So first part, I will show you how to assemble them. A second part where I will show you how we can animate them using the mechanism system design and experience application. Okay, so first of all, let's get the assembly. So I will upload that on GrabCad, and you will have to, you can find it on the link below. And this one will be the Double Cardan assembly to mount. And I will start by this one. So as you can see, I have spread the different parts in the assembly design. And as you can see, all of them has been moved because you have a tiny yellow sign next to the blue 3D part, meaning that this part is not at the 0. So what we will start with is we will take the fixed part. We can hide the other. And I will take the fixed part and go to properties, and you have to go to the position tab where you can find this reset button here. So when you click here, you see everything goes back to what it used to be before. Apply. And now what has changed is this blue part does not have the yellow sign anymore. And now it's in the 000. Okay, so the fixed part should be fixed in the assembly. You always need to have a fixed part if you want to have some motion in your assembly. So there is two ways. First way, you can just click on the fixed button there under the engineering connection, or you can also select the engineering connection button. You will have this panel that appears, and you can just select this part, and it will be considered as fixed in the assembly. Okay, now what we will do is we will select two other parts to bring, the move part, that's the other gear, and the bar in the bottom. So now we will fix this three parts together, and the way to do it is I will select this hole here and this axis here, and you see axis to axis will become a cylindrical. Now if I select the plane on top and plane here, now you will get Revolute here. So I click on OK and no contact, great, and I update. Another thing here is I have selected a special view, customized view here, where I hide the wire axis and points, so we might need the plane later, so I just go back to shading with edges. Okay, what else now? I will add the same revolution in this two part here, so axis to axis, great. And now I will also select this plane here and the plane there. And the good thing is, as you can see, this connection is only between these two parts. So this one here is hidden. I click on OK and update the button. No problem, everything is going back. And something to also help me here, I will not create an engineering connection, but just use snap mode here to just say I want my yellow part aligned with this blue one here. Okay, and as you can see, it's just going to move it quickly, and I just update, and now it's getting a bit better, and you can do the same with this one as well. Update, okay. You see, it's pretty simple, and I have not created any engineering connection, I just move it. Okay, great. What do we need to do next? We need to create a gear connection between this gear here and this gear here. So to do a gear, we need two things. We need two revolutes. We already have them, but we need two revolute with an angle command or a hinge. So how do we create an angle command? We go to the revolute here, I double click, and we will basically say I want an angle from this plane and this plane. So you right click on the type, you insert the not offset but angle, great, and you select the two plane, this plane here and this plane here. Okay, here the value is 180, it's no problem. But you see there is a small panel, a small sign here saying that there is an update. You click on the lock, now it's becoming a rigid. And this is not what we want. We want still a revolute, but with an angle command. So in the mode here, we will select not driving, but controlled. Meaning that control will give us later a command to control that. And now it's going back to revolute again. I click on OK. And I will do the same with this one there. And the thing you can do is I can also, from there, you see I did not update the revolute. I just select angle, I created a new internet connection. I select angle between this one, and automatically the software will find you actually work on the revolute. Now do you want to enrich this connection? So you click on OK. And now it's going back to the revolute with adding the selection you had. And same as before, you don't want a rigid, you want a control. We're going back to revolute. That's great. Okay, another thing. Here we have indeed the revolute here, but now we might want some angle. If I put 0 here, it's going back in the other direction. Okay, so 180 is okay, but you want to have some lower value here. So what we could put 150 maybe, and 200, let's see, 180 plus 30. Does it work that way? It also works that way, great. So what does it say now? So if I say 150, that's the limit we will reach. And if I say now 210, this is the limit it reach. Okay, so I go back to the middle, 180, no problem. So now we just basically added some limit to that angle. And well, technically you can also do the same here. 150 and 210. Okay. So far so good, we have created the two revolute with the angle. Now let's create the gear connection. So you go to engineering connection and you select gear. And you have a small wand, magic wand here that appears that help you to find what you need to select. So you need to select 2 hinge or 2 revolute with an angle. So you select revolute 2 and revolute 3. And now it's creating this value here. So if you don't really understand, basically it's creating a ratio. So here it's 57 degree, or you can change that, it's no problem, but it's just depending of the number of teeth you have in your gear. So you can actually control the ratio in that gear. I will keep it for the moment like that, click on OK. And what I like with this assembly design now is you can just basically just play with the robots. So let's see what we can do. Can I move this part here? Yes, it seems working, so it's pretty good. I can just move manually. That's pretty nice, and it's on live, and as you can see, the part below also move. Update, going back to the original 180 degrees. Okay, let's now insert the other part. So we want to have the prismatic here. So the prismatic, we want maybe something like that. So you don't need to do that, but I normally do it myself to help the software to also find out the good orientation. So you select this plane and this small plane here, okay, and the same face here and there. So here we have a prismatic, no problem. The only thing we want now is to have some value to go up and down, because as you can see now, if I move up and down, it's no problem, but I'm going over the limit. So what can I do here? I can again select creating a new engineering connection, or I will select the two different planes. You see this one, and now the software said you want to enrich the prismatic, and I say yes, I want to enrich that, except that it is not a contact I want, it's an offset. And you update here, okay, remember to select control, now it's going back to prismatic. What do we want? Here we want the maximum value will be 50 millimeter, okay, and the lower value should be 0. It should be 0, but actually you will see later that when we'll bring the cardan, that actually if I put 0, the cardan will be inside the blue part. So I will just create a limit that is higher than 0. So you update the prismatic, and I will say the limit minimum should be 20. Okay, 20 there. And it's okay to do it even if there is no real block or real limit. You see, it work as well that way. Okay, so far so good. We have created the prismatic. Now let's bring the cardan. We have the first one. So this one is pretty simple. Basically, you say you want an axis to axis, and the face here against this face there. Okay, let's keep it that way. So far it's a Revolute, there's no problem. We will change it later to a Revolute with command, because this will be an engine, or it will be actioned by an engine. So we will add some angle connection to do later a command. Let's continue. Let's bring now the other cardan. So axis to axis, and plane to plane. Okay, good. Let's continue now. I will bring the cross, because you need the two cross for each cardan. Simple, you select this axis to axis, and you select here this plane, again, this plane here. Okay, no contact. I will do the same with the other cross. Axis to axis, and plane to plane. And what I like also here is you see all the other parts are becoming transparent. So technically I can just, as you can see here, I'm going through this yellow part, and I can just select this. It's really nice, and it's a good user interface for assembly design. Okay, let's finish with the two other cardan. So the purple one. Okay, you select this hole here with this one. Okay, so it's moving the parts, there's no problem. And you select maybe the top face with the top face of the cross. Here it's okay, no problem. We will just, there is a clash because you have a clash with the green part. There's no problem for that. I will just select my robot, and as you can see, I'm putting the robot on the cross to use it as an axis. And after I select the purple part, meaning that I can just rotate this one against, or using the robot on the pink cross. And finally, the last cardan, the yellow one, and this one is more or less the same. You select the two hole here, and we select the face. So this face, again, the face below. Of course, here is going to say maybe there is a clash. No, there is no clash, no problem. And we finish. This time, again, I could help the software to just select this and say you want it that direction. And the last feature will be to have a prismatic between this purple one and this yellow. I first start creating a cylindrical. You will see here, if I update, now it's good, and I will just add some connection between this purple and yellow. So as I can do it before, I will this time update the cylindrical directly. You have two ways. Me, the way I prefer would be to select the plane, because then you are sure it's perfect, especially if you have some issue in your geometry. Or you can also select the surface to surface. So let's select the plane to be sure that we are more robust, I would say, in the way. Okay, plane to plane, update, prismatic, no problem. Now we can just play a bit to see if it's working. Okay, let's start by the prismatic. This prismatic is working. Great. Let's do this one to see if we have indeed some rotation. We have some rotation, that's good. And we finish with the last one, the gear. We go back here and we say, okay. And now we can see that everything is working. I update, everything will go back to the original value. And I will finish the design by adding, as I told you before, a small angle connection between these two planes here. So this plane here and this one, between the prismatic block and the Cardan A. Yes, I want to enrich my Revolute. Remember, we replace to angle, we change that to control, so then we are going back to prismatic, to Revolute, and I put 0 degree. I do not put any lower or upper value because it's going to be an engine, so it's going to rotate 100%. Click on OK, I update, and the first part of the video is over. Now we have created an assembly with several connections, and so far you can just manually move the parts, but now I'm going to show how we can add some command to it. So the second part here is to switch to mechanism system design. So I have it on my favorite here, or you can also search on the search bar here. Okay, mechanism system design. It looks like exactly the same as assembly, except that here we can create a mechanism. This mechanism representation will be in the product. So mechanism Double Cardan, enter. What does it say? It finds all the connection in your assembly, he lists them. You can see mechanism manager, okay, he lists them, and then he say all the command you have. And here, if it's orange, it's because there is the degrees of freedom is too high. Number of command 4, degrees of freedom you have 3. So basically we have to remove one command, and the command we want to remove is actually this one here. This, because we have the gear saying that it's controlling 2 angle here, but we only need 1. So I will just select this one and remove the angle, as you can see there. Click on OK, and now as you can see it was green. You have a tiny sum there. It's green, no problem. Okay, and what can we do? You will see here in your mechanism that you have some command. You can click on the mechanism player, and now what we can do is we can, instead of using the robot, we can use this mechanism player just to verify with a slider. Okay, and it's rotating, okay, and we can also move that. It's no problem. Close. Okay, it's going back to 0. And third step of the video now is we switch to mechanism system experience to do an animation. So I can also go back to my custom view because we don't need this plane anymore. So it's a bit nicer to watch. Okay, and remember to save. And now we will switch to mechanism system experience. So you see I'm just searching it. So not design, oops, it's system experience. And you say, yes, I want to create a simulation file because this is going to create a simulation. Kinematic simulation, I will just call it simulation or sim double Cardan. Click on OK. The thing is, the simulation will be on another file. You see, it's just opening the product in the simulation. Okay, what do we do now? We have to create some, as you can see here, you have some excitation on the command. We have to create that. So the first one can be easy. It's going to be the motor excitation of this command here. So basically just turn. So we can also change the name, it's no problem. We can call it motor. And it's asking you the command you want, and the command will be the one, as you can see here, from not the fix to the bar, but from the fix to, no, that's the prismatic. The last one is from the prismatic block to the cardan. And here we can just say we want a speed of 100 turns per minute. Click on OK. You can see it arrives on the excitation bar here. And we create two other excitation, but this one will be position. Why position? I will show you here. We are going to say that we want to control the prismatic, so prismatic block and fix, okay? And I will change the name to prismatic. And I will select this command here. And there is two types, distance or oscillating. Distance, basically you start at here 5 seconds and we will go up to 10 seconds and we'll just move only one time. Me, I want to do oscillating. Oscillating here, and I want to say it's going to oscillate 30 millimeter, remember, from 20 to 50. And I want to have a frequency of 1 Hertz. So basically in 1 second, it will go back and forth. Click on OK. Great. And now the last one, we want also a position. Did I select the good one? Yeah. Position motor of the gear. Okay. So I will just rename it gear. We select the last Revolute, this one. Okay. We want as well oscillating 1 Hertz. That should be enough. And how much deviation you want. Here is going to be only, if I'm correct, we can put minus 30, I think it's that, or 60, maybe 60 degrees will be from both sides, okay? And this is a bit complex to understand, but it's if you only put 60, it's going to do from 0 to 60 degrees. So you want to have some delay, and we will put 90 degrees here to be sure that it goes in both directions. Normally it should work, let's see. And finally, so we have created the excitation. Now we have to create the scenario. Okay, it's a dynamic scenario because we have some position. You want to bring the 3 different excitation, motor, prismatic, gear, and we'll go to parameters and end time. You could put 10 seconds, but it's not really the point. It's going just to do the same movement. So we just put 1 second. That's going to be okay since we have put 1 Hertz. Click on OK. And now what you need to do, we can update. You see the scenario has a grain sum. So now we can do is just run to be sure it's working. Okay, so that is there is some problem of inertia because we haven't put any weight on that assembly, but it's no problem. We just wanted to see the position, okay? And now we are going back to the result mode. So what we can do is we can just replay what we have seen. And it takes a bit of time to do the calculation because it's calculating all the steps, but this is no problem. As soon as it's done, you can replay it. And as you can see, we can also change the mode. Maybe this one is correct. Yeah. And you can also accelerate this motion or going a bit slower. So what you can do from there is if you have a third software like me, you can just record that. Or you can also, if I'm correct, I just escape that. There is also in tools, you have a record function here. So if you want to record the screen, you can do a video of that. Okay, and what can we do that can be nice in that application is you can have some plot or some graph of what you have for each part. And I think this is pretty interesting if you want to learn more about the movement. And if you knew that when you have a double cardan, often you have this sinusoidal motion. So here we can see it pretty well. So that was pretty simple, but now what I like is swept volume, and I think this is very interesting. We are going to create swept volume of one part. Okay, click on OK, and now, sorry, it appears on a second window. You select all the elements you want. I just want to select the purple one, so I just remove all the different cardans. Okay, and put something, it's going to make a reverse engineering scan, basically. So put something pretty high. 1 millimeter should be enough. We don't want to have something too precise. Click on OK. And basically here it's showing you the orientation of the part, so we can bring that in the assembly. Okay. And here, this is the motion of the purple part. So I think it's pretty interesting here. You can see all the volume swept by this part. I even think you can modify that. It's a cloud of points, so you can modify that. Properties, cells, and you can also change the color. White if you want. And it's not the most beautiful thing, but you can also put transparency, apply, and yeah, you can see, it's not perfect, but you can see more or less the part inside, and you can see the motion. I will hide because it takes more resources. So that was it for me today. Thank you very much for watching the video. If you want to see more videos like that, subscribe to the channel and do not hesitate to comment as well. And finally, I would say thank you very much for all of you to watch this video. Have a nice day. Goodbye.